Sure you don't want to pick a harder one?
Yes.
Teasing. This looks plenty hard.
Yeah.
Let's have a look at it here. Let me get something right. Find x. Wow. You understand this?
Yeah.
Okay. In other words, given that the hypotenuse is x and the side length is 6, then the horizontal length is square root of x squared minus 36.
Mm-hmm.
Okay. Same thing on the other side. This is an isosceles trapezoid. And the total length is x plus 2a. Well, let's fill in everything. If we fill in, we know what a is, right?
Yeah.
So let's fill in. What is x plus 2a?
X plus 2. Wait, what?
They want to know what, oh, excuse me, sorry. This distance here is x plus, I'm confused. Why is that an equation? Oh, because it's x plus 2a, which is this side, and that side. So that whole thing's equal to 26, that distance.
Okay.
Okay. So what do we do now? Let's see. We certainly can say, if we're trying to solve for a, well, let's substitute for a. What's a equal to?
2? Wait.
No,
Right?
a is equal to that.
X squared minus 36.
Uh-huh. So if I have x plus 2a equals 26, well, that means x plus, what is a? 2 times that? You with
X
me?
squared minus 36.
See how I get to that equation?
Yeah.
Okay. They tell us what a is. So all I'm doing is substituting that in for a. Now, it's a relatively simple problem. It's a straight algebra problem. There's only one variable. It's x. It's kind of a difficult one to solve, but not that hard.
Okay.
When you have a radical sign in an equation, your goal is to isolate the radical sign and then square both sides.
Okay.
So, how do I isolate the radical sign?
What'd you do?
What have I got to do with this x?
Subtract it.
Okay? In other words, I got to move it somewhere other than the left side of the equation. Because I don't want it to be on the left side of the equation. I want it to be on the right side of the equation. Now what?
Divide everything by the 2x and then.
Just by 2.
Okay.
Now I've got the radical sign isolated. I got this on the other side. What's my next step? In other words, once you get the radical sign isolated, you want to square both sides.
Okay.
Well, that leaves me this on the left. How do you square that?
13.
Squared.
You just do the, yeah.
Minus 2 times this times that. That's 13x. Plus
Oh, I got it. Okay, yeah.
x squared over 4. In other words, this is the right side squared.
Okay.
Okay. Now, at least I have what looks like a quadratic, right?
Mm-hmm.
What's the best way to solve this quadratic?
By subtracting it? By dividing it?
We know we're going to end up with a quadratic that we're going to have to factor, okay?
Mm-hmm.
Well, if I move everything over to one side, I'm going to have a complicated fraction in front of my x squared. It's going to say 3/4 x squared.
Mm-hmm.
So to avoid that, let's get rid of this denominator. How do I get rid of that denominator?
By multiplying it,
By
I think.
multiplying every term in the equation by 4.
Okay.
You have to multiply everything by 4. Okay, and that gives me this. 4x squared minus 144 equals, what's 4 times that? 6, 7, 6 minus 52x plus x squared. Now we don't have any denominators. So it's all I got to do is put everything on one side and solve the quadratic, and I have my answer.
Mm-hmm.
Well, help me. Put everything on the left side. What do you get?
So would you subtract the 676 first?
You want to put everything on the left side. You can do it in any order you want. You got to bring the 676 over, you got to bring the negative 52x over, and you got to bring this x squared over. Let's start with the x squared. What am I
So
going
then
to have on the left?
3x squared.
What's the x term going to be?
What?
What's the x term? In other words, I'm going to end up with a quadratic on the left and 0 on the right. So I got to take this minus 52x and move it over to the left. What's it become?
Plus 52x?
What's the number? I got a minus 144. I got a minus, I got to move the 676 over. So that becomes minus 820. I think when you subtract 676 from 144, I believe you get 820.
Okay.
That's equal to 0. Now, the question is how they expect you to solve this. That's not a problem you're going to be able to factor easily. First of all, the numbers are too big. 820, who knows how to factor this? It might take me 15 minutes to figure out how to factor that. So how else are we going to solve it?
By square
We
rooting
don't
it?
even know it can be factored. It might not factor nicely. So what's the best way to solve it?
Could you square root it?
No.
Uh,
You have a calculator that you know how to solve quadratics on?
I think so.
Well, I think that's what they intend here. for you to use is your calculator. Merely because this is an extremely difficult quadratic to solve manually by factoring. There is one other way to solve it, which always works. Quadratic formula. So what's the quadratic formula? What's the general formula?
Where'd it go? I wrote it down.
You don't want to have to look this up, Haley. You need to memorize this.
Negative b plus or minus square root. I mean what's that called? The
Square root.
yeah. Square root b squared minus 4ac and then divided by 2a.
Yeah. If you don't have this memorized, work on it.
Okay.
You do not want to have to look this up every time. For one thing, you'll never memorize it. The only way to memorize something is to test yourself periodically. Make sure you've got it memorized. If you had this written on a sheet of paper and that sheet of paper was always in front of you, guess what? You're never memorizing it. Seriously, that's just what happens. If you're always looking at the answer, you're not going to memorize it. But if you turn that piece of paper over so you don't see what it is, and then you try to remember what it is, after 2 or 3 times of that, you'll remember it. But this is definitely one of the most important formulas you can memorize in algebra.
Okay.
Now, what's A, B, and C?
A, B, C. A is 3. B is 52, and then C is negative 820.
Okay. So we got to fill all those in. So tell me what to write.
So negative 52 plus or minus 52 squared minus 4 times 3 times negative 820 over 2 times 3.
All right. Now, when you're solving something based on the quadratic formula, there's a lot of mistakes that it's really easy to make. One is how you handle this part right here. I tell everybody to do that first. Come up with a number and then subtract that number from 52 squared. What do you get?
Hold on.
I don't know why the schools do this, where they give you these giant numbers. I don't know what they're trying to prove. I mean, this problem would work just as well if we were dealing with 2s, 3s, and 4s instead of 52s and 820s.
Yeah.
That's why I'm pretty sure it was meant to be done on a calculator.
Yeah. If I do negative 4 times 3 times negative 820.
Stop for a moment. Don't ever put the negative sign inside that circle. That is subtraction, first of all. That's not negative 4. That is 52 squared minus whatever result you get when you do these 3 numbers. So what is 12 times minus 820?
12 minus 820. It would be 1872.
And that's a negative 1872, is it not?
Yeah, it is.
That's why it's easy to make a mistake. And that's why I tell everybody not to put that first negative in there. Solve for AC first. And now, do 52 squared.
Oh, I think I did 52 squared with it.
Oh, I don't think that's a net answer. No. Oh, maybe it is. Oh, you did 52 squared minus that?
Yeah.
No, that is about 1872. Is it not? Let's see, 12 times 820. No, that's like 8,000. My apologies.
Oh, okay.
Something's wrong, though. Tell me what 52 squared is.
2,704.
And we are subtracting a negative. What's 12 times 820?
Hold on. Wait, 12 minus.
No, 12 times 820. Just give me that.
9,840.
So now you can see that you got to add these two numbers. Go ahead and add them.
2,704. 12,544.
Now take the square root of that.
Wait, what?
Take the square root of 12,544.
12. 12. 122. 112.
Exactly?
Yeah.
Okay. So there's our answer. Right there. There's our two answers. Now, we got to do some simplification. Make sure you know how to simplify it. And incidentally, what that tells us is that it actually was factorable, but who would have been able to figure it out? I mean, so I didn't even try to factor it. What I just immediately assumed was we were going to have to use the quadratic. So what answers for x do we have?
There's for x.
Take minus 52 and add 112, divide by 6. What do you get?
Plus 112. 70.6.
No, if I add 112, I get 60 in the numerator.
Wait, negative 52 plus not 112.
It's not 152, it's 52.
Yeah.
Minus 52 plus 112. What's your calculator say?
Hold on. Minus 52 plus 112.
That doesn't give you 60, you're doing your minus 52 wrong. What kind of calculator do you have?
I got 60. I have a TI-83.
Okay, so now we got 60 divided by 6. So one value for x is 10. What's the other value for x? Now you have to do 50 minus 52 minus 112. That's minus 164 divided by 6. What is that?
Negative 27.3.
Now, which one of those answers doesn't make any sense?
The negative 27.3.
So we throw it out. In other words, when you produce two solutions, there's nothing in math says that both of them have to be right. What math says is that one of them has to be right. At least one of them. Frequently, both will be correct. But when you're talking dimensions here, then negative doesn't make any sense. It's like if you were solving a time problem and you came up with two times, one was positive and one was negative, you'd throw the negative out because there's no such thing as negative times. And you'll notice that it's not totally obvious. You could put in the negative sign into this and it would work just fine because it would turn positive. But what you can't have is a negative x, because that is the dimension of that hypotenuse. It's also the dimension of that rectangle, and it's the dimension of that hypotenuse. So there's no way negative x values work. So
Okay.
10 is the answer. Now, might be worth checking it, especially if this is the only one we're doing tonight. If that's 10, and that's 10, and that's 10, and that's 10, well, what is this? 100 minus 36, that's 64. Square root of 64, that's 8. That's 8. Now, is 10 plus 2a, a is 8, so 10 plus 16, is that 26? Yes.
Yes.
Works. So x is 10.
Okay.
Now, that was pretty difficult, but not really. Not once you know how to solve equations where there is a radical sign. In other words, the first thing we had to do was we had to add that plus that plus that gives us 26. In other words, x plus 2a is this, x plus 2a is this length plus that length plus that length. And they've told us that's 26. Well, since I know what a is as a function of x, I can substitute it, and I end up with one equation and one variable. And you can always solve one equation and one variable.
Okay.
Any other problems on this page you want to talk about? And
We can do number 3.
number 3?
Yeah, it's on the other one.
That's on the other page, or?
Yeah.
Okay. Let me get there. All right, completing the square. This is something you have to do a lot in algebra. Solve by completing the square. First of all, let's talk about completing the square. I am going to take these two terms that both have x in them. I'm going to isolate them, and then I'm going to complete the square around those two terms only. Well, that 10 is just getting in the way, so let's move the 10 to the other side. And leave room to complete the square. How do you complete the square? Hold on. Why would they do this? Okay. All right. That's all right. I realize we are dealing with imaginary numbers here also. But let's talk about the process of completing the square. Once you have the x squared and the x term in parentheses, the process for completing the square is to take half of the coefficient of the x term and square it, and always add it. So what is that? What's half the coefficient of the x term squared?
2.
What's half the coefficient of the x term?
Is the x term 4?
Uh-huh.
And then,
So what's half of that?
2.
Now square it.
So
2 squared.
4.
That's how you complete the square. Now, I just added 4 to the left side of the equation. What do I got to do to the right side of the equation to balance it out?
Add 4.
Now it's the same. In other words, these two are the same. Whenever you're completing the square, the goal is to make sure that when you go from line to line, you don't change anything. This second equation is the same as the first. I just have manipulated stuff. I've moved the 10 to the other side, and I've added 4 to both sides. Now, the reason you complete the square is so that I can write this as x minus 2, a binomial linear term squared. Now I'm going to solve the problem by taking the square root of both sides.
Okay.
That's why I put the 10 on the other side. It's because I knew I would get to a point, whenever you're solving quadratics by completing the square, you're going to have a linear term squared equals a number. Now what?
You square it, right? And then
Square root both sides. If the term we're trying to solve for x, so I got to get rid of that exponent and I got to get rid of that 2. So the first thing to get rid of is the exponent. So when I take the square root of both sides, what do I get on the left? What's the square root of that?
8.
What's the square root of x squared?
10. What?
What's that equal to?
Square root of x squared. It keeps saying 10.
It's not a number. It's x.
Oh.
Right?
Mm-hmm.
The square root of any number squared is that number. If I said, what's the square root of 7 squared? It's 7. If I say, what's the square root of 8 squared? It's 8. So when you have x squared, the square root is x. So what's the square root of x minus 2 squared?
2.
It's x minus 2. What's the square root of negative 6? Always you want to begin your answer with the words plus or minus, because anytime you solve an equation by taking the square root of both sides, your answer begins plus or minus. And the answer in this case is square root of minus 6. Okay? So you see how I went from that step to that step?
Mm-hmm.
Okay, so all I did was take the square root of both sides. Now I'm trying to solve for x, so what have I got to do with this 2?
Add it or divide it?
No, add was correct. The 2 is being subtracted, so you're always doing the opposite of whatever it's doing. If it's being subtracted, you need to add it. If it was being added, you need to subtract it. If it was a multiplier, you would need to divide by it. If it was a divider, you would need to multiply by it.
Okay.
What are my 2 answers?
In
other words, that gives you 2 answers. What are they?
2 plus 4.4 and...
No, I don't want answers like that. I want answers like square root of 6i.
Oh, okay.
What's the other answer?
2 minus square root of 6i.
Yeah. In other words, at this point in algebra, you never convert these square roots to numbers. They want exact answers. The only exact answer is square root of 6. You can turn that into a decimal all day long, but you're approximating. You're not giving an exact answer. There's no way to give a decimal answer that's exact. The only exact number is square root of 6. So there's your two answers. Solve the quadratic, you would expect two answers. We get two answers, and we got it by completing the square. But remember this process for completing the square, because you got to do that a lot. You got to do that to get a quadratic in vertex format. You got to do it to solve circles, ellipses, hyperbolas, parabolas. Completing the square is one of the most fundamental things you can do in algebra. So remember how to do it so you'll know in the future.
Okay.
Okay? I'm going to let you go. I got to run. Haley, I'll talk to you next time.
Thank you.
You're welcome. Bye-bye.
Bye.